Fall effect in Houdini. This is going to be a beginner friendly tutorial, so if you are an intermediate or an advanced user, feel free to skip this. And yeah, let's get started. So as you can see, there is this snowfall happening in my view right now. Let's break down this a little bit, and we are going to create everything from scratch. So yeah, I have a camera which I'm currently viewing through, and I have a geometry node which is where all the snowfall is happening. So yeah, I have a grid, and I'm using this grid as an emitter. So we have something like this, and I'm just moving it a little bit higher using the transform, and we are doing something here, and we are connecting to the pop net to get something like this. We have something going on inside the pop network as well. We will talk about this soon. And we have a ground here, which is just a grid and some along with some mountain top, so that we have some deformation on it, and we are going to use this as a collision. So in this we will learn how to basically emit some particles, and we will see how to use collision, how to use a custom geometry as a collision object, and also we'll see how to control some particle behaviors. So yeah, those are the things that we are going to see in this tutorial. So let's start from the scratch. So I'm going to delete everything. Let us rebuild everything from scratch. So I'm going to drop a geometry node, and I'm going to name it as setup snow. So that's how I used to name my setups. And let's jump inside. So let's create a grid. So yeah, we have some basic grid here, with some divisions. I would like to increase the subdivisions. So let's put 3 here so that we have more divisions. We can do it over here, but I prefer doing this so that I can just have one slider to control. So we can put even higher numbers here, but let's keep 3 for now. So this is going to be used as a emitter. So we need the snow to be emitted from above the ground, not on the ground itself. So we are going to move the grid a little bit higher, something like this. So it's going to start falling from the emitter to the ground. Yeah, now let us drop a pop network and connect it to the first input. So this is going to create particles from this by default. A pop net from the tab menu here, the pop network is just a simple DOP network, but with some custom presets inside it. So both are just same node, but they have added some nodes inside for us as a preset, so that we can just start working on it directly instead of having to create everything from scratch. So yeah, this basically consists of a pop object node, pop solver, and this is just a merge. We can delete it, you don't need it, and a pop source. These 3 are the main nodes which are used to create the particles. And let's see what they are doing. The pop source, this node is the node which brings in this source object inside the DOPNet, inside the simulation space, and this node is generating new particles and giving it to the solver to move it basically. And this is the object, which is basically a container to store all the particle data. And this is the solver, which actually calculates the movement of the particles and all other attributes. So yeah, you don't need to remember all those things, but you just need to know what these things are. basically. So yeah, if you press play now, you can see it's generating particles, but they are not moving at all. It's just spawning and staying at the same place because we don't have a gravity. So as soon as you think about it, the first thing which comes in mind is just using a gravity force. So if you connect the gravity force, it's going to make the particles fall like this. Yeah, it works, but we have some problem here. You can clearly see there are some kind of weird banding here. If you move the camera up and down, you can see the banding moves as well, which is really looking weird. You can turn off or on this icon to visualize the velocity of the particle. So yeah, if you see something like this, you can turn off that. And you can also you need to also click on this particular time button, the clock button, to make the viewport play in real time. What I mean is currently the viewport is playing in 24 fps, which is set here. If I put to 25, the viewport now should run in 25 fps only if you press this button. If you do not have this enabled, this will make the viewport to run as fast as it can. So see, it's going to run really fast, which is you are going to make wrong decisions if it is going to play it this fast. You may think that the simulation is running really fast. You may think the snow is really falling really fast, but actually it is just playing the animation as fast as it can. It's not running in real time. So if you press this button, it's going to play it in real time like this. So yeah, so you need to enable that for sure, and you can enable or disable the velocity if you need. So let's fix this banding issue first. So banding or stepping, whatever you call this weird artifact. So if you use this gravity node, you don't have much control on it. So what I would like to use personally is pop force, which is just a force node to affect particles. Basically, you can connect it to here. Notice that I connected the gravity node here, but the pop force here. So all the pop nodes, you need to connect it to this third input. So if you search pop, there are a lot of tools that you can play around with. Everything needs to be connected to the third input here. But if you find some nodes like this, this is like a global force or something like that. But I think you can just avoid these nodes for particles. You can just use these pop underscore nodes. These pop nodes are enough to work with particles. So most of them needs to be connected to here. And yeah, so I have connected the pop force now. Let's see what happens. Nothing happens because we haven't put any values here. So we need to put -10, or if you take the gravity, so you can see the gravity is -9.80. We can put the same value here, just close to 10, but you can keep it 10 or 9.8 as you wish. So let's hit play and see what happens. Yeah, again we are getting the same effect. We are getting exactly same what we had in the gravity node, but we have more controls over here so that we can break this ugly banding effect. So let's see how to do that. So if you enable the Vexpressions, use Vexpressions, this is going to give you this panel. Don't worry, I'm not going to give you any expressions, or you don't have to write any expressions yourself. You just need to click this button and click on randomize magnitude. So this is going to give you the expression which removes this banding. So basically what it does is it just creates a random number based on the particle ID. So each particle is having unique ID. Based on that ID, it just creates a random number, and that random number is getting multiplied with this force. So each particle is getting a different, slightly different force. That way everything doesn't fall in exact same manner. So if I disable this expression, each particle is getting affected in the same way, because everything has the same force. But if you use this expression, then each particle is going to be affected by this force, but along with that, that force is going to getting multiplied by this random number, so that each of the particles is going to move in slightly slower or faster when compared to each other. So that's how you break the silhouette of that banding or the stepping artifact, whatever you call. So we have really nice falling particles now. That's really cool. Yeah, now the next problem is the particles is just going straight through the ground. The simplest way to add a ground is just using the pre-made ground plane. So you can use a ground plane node here, and to make it collide with the particles, you just need to connect it below the pop solver. So you can select both and click Alt and drag from this dot or this dot to create a merge, or else you can create a merge and just connect it like this. Both works. So based on your preference, you can do that. I basically like to just drag it like this and just connect. So yeah, but when you are connecting this, you need to make sure that your ground plane is connected to the left input and the pop solver connected to the right. So if you press play, you can see the ground is getting collided. The particle is getting collided with the ground object. Yeah, as you can see, the ground plane seems small, but actually this is an infinite ground plane. This is just a representation of the ground, but even if you put some particles over here, it's going to fall down and stuck on the ground, because this ground plane is just an infinite ground plane. We can disable the ground plane. I mean, you can disable the visualization ground plane if you don't like, by just pressing this button, and if you go back, it should disappear. So you can see the ground is still working, but it's just hidden from the view. And we can see the next problem now, which is the particle bouncing. We don't want the particles to bounce because the snow usually doesn't bounce, right? So to fix that, we just need to go to the pop object and go to the physical tab. You have some controls over here. You just put 0 in the bounce and mount forward to restrict the bounce. So yeah, as you can see, it just falls and sticks down. Currently the particles just fall straight and it doesn't have any wind at all. So let's add some wind to make it more realistic. So to add wind, there is a node called pop wind. Just connect it below the pop force. Let's use this only for gravity. You can use this to add noise as well. Like you can use that like a wind as well, but I prefer to use this as a use this only for the gravity and add wind with a separate node. So the pop force and pop wind are pretty much same, but pop wind has this air resistance, so that the particles, the force have some resistance to it, air resistance, so that the particles behave slightly more natural. So we have added pop wind. Let us put some numbers here. Let's put 1 in the direction. So the wind velocity is just the direction parameter. So if you put 1 here, it's going to push the particles in x-axis. If you put 1 here, it's going to put the particles in z-axis. So I'll just put 1 here and let's see what happens. So yeah, you can see this is like pushing in this particular direction like this. If I increase the value, you can see it more prominent. So yeah, so it is pushing in particular direction, but wind is not always going to be like really constant. It's going to be turbulent. It's going to make the particles swirl and like move in noisy way. So let's replicate that by using this noise controls. So if we increase the amplitude, let's put 1 here and see what happens. You can see they have slightly like particles are moving in slightly different directions. To make it more prominent, let's put 5. Yeah, as you can see, the noise is applied a lot now. Obviously this is too much. I'm going to reduce the wind speed and the amplitude to 2. Yeah, that's slightly better. And we can also set the swirl size to 2. The swirl size is the size of the noise which is getting applied. For example, if I put some values like 5, it's going to make the particles swirl in a larger pattern like that. You can put 50 to see it even more better. So yeah, now it's like applying the really big noise so that most of the particles move along together. So we can adjust that using the swirl size, and we can adjust the amplitude to make it more prominent or less prominent basically. So if you put 10, the amplitude is basically the strength of the wind, and this is just the size of the noise pattern. So I'll put 2 in both. I think it's fine. Maybe I can put 4 here so that it's more elegant. So yeah, we got something like this. So we need a camera. Let's go to a preferred view, something like that, and we can click this button and create new camera. So yeah, we have something like this now. It just creates a new camera from the current view. You can just name it to this camera and jump back inside. So far we have created a grid and just moved it and used that to emit the particles, and we have also added a simple ground plane to use as a collision object, and we have controlled the behavior of the particles like gravity, and then added wind. We have also like adjusted the physical parameters like bounds. So far we have done that. Now let's see how to like use a custom ground plane instead of this default like simple plane. Let's do that. Let's create a custom ground plane first. Let's take this grid and just take a copy of it and just increase the divisions. Maybe I think we can just use the same method. We'll just take the grid and subdivide it even more, and I'm going to make the ground a little bigger. This time I'm not going to move it. Okay, let's go with 3 for now. Yeah, we have some ground now, and this is again a flat plane. I don't want that, so let's add a mountain saw and connect it to the transform. Give something like this, but I want the ground to be more even and less noisy. So let's increase the element size. Yeah, that's more realistic. And we can also, if you want, you can reduce or increase it. I'm just going to leave it for now. So yeah, we have something like this. To make it more prominent, let's increase it even more so that the effect is more visible, but based on your preference you can reduce or increase the height. So let's name this as ground, and we can basically like import this into the DOP network and try to collide, but a thin geometry like this, just single-sided. So if you click this button, you can see the bottom is blue. This is the back side of the polygon and this is the front side. So basically for collisions it's always better and ideal to use a closed geometry instead of using like thin sheet of geometry. So to create some closed geometry you can use a extrude volume. This just creates an extrusion like this, and it's going to flatten the base of the geometry. So for ground collisions I prefer to use this node. This gives you a simple closed geometry. Now you don't have that blue back face anywhere because it's just completely closed now. So using a closed geometry is ideal for collisions when you are doing POPs or any other DOP simulations. So let's drop another null. Sorry, not this one, just a null, and let's name it as our collision and go inside. So instead of using this ground plane, we are going to use a static object, and we are going to copy this, just Ctrl C and paste it here, so that it just imports this particular object as a static object in this node. So now instead of connecting this, we are just going to connect this. So as you can see, immediately this brings that static object, the ground object, inside the DOPs. So if you press play now, you should see the particles fall and stick to the ground. If you go to the camera, you can see it better. So yeah, it's colliding pretty accurately, but you can improve the collision object by using some advanced techniques. I think for now, I think this is enough for now, and basically that's it. We have covered like whatever we planned for this tutorial, but I will make another part where I will show you how to render these particles, how to make more advanced emission, more advanced controls of the particles, etc. I will make a part 2 if more people like this video. I hope that's useful. Let's meet in part 2 if you really need it.